All right, guys, this is a review of factoring trinomials in x squared plus bx plus c, and this is assuming that we have a 1 in front of the x squared. We're going to do this by following the old school steps and then also checking it on Desmos, because sometimes you just skip out to Desmos and get it done. So it looks like x squared plus 9x plus 18. The first thing in the old school method is saying, hey, we got to find two numbers that multiply to c and add to b. And c is the last value in the equation, and b is the linear term in the middle of the equation. So if I was to go ahead and use the area model to do this, I'm going to say, okay, here is our box, and I'm going to say I got x squared and I've got 18. And what we want to do is go ahead and say that we want to find the two values right here at the diagonal that add to 9x, but they multiplied to this value of 18. So I like to start just by getting the easy stuff done and saying, well, let's put an x and an x right here. Because x times x is x squared. And then what we want to do is say, okay, what numbers multiply to 18? So that is 1 and 18, 2 and 9, 3 and 6, 4, that doesn't work. 5 doesn't multiply to 18, 6 times 3, so we've already repeated ourselves. Now, what we're looking for, 3 times 6, all these add to 18. What we also want to do is find out which ones add to 9. You'll notice 3 plus 6 adds to 9. So what I'm going to do is I'm going to insert this, maybe say 3x plus right here, 6x. And what that means is that we would have x plus 6 and x plus 3 on the outside. And that's because 3 times x is 3x and 6 times x is 6x. So this factors to x plus 3 and x plus 6. Now, of course, we can go ahead and check this on Desmos, always verify. And you know what? Some of you are probably going to go straight to Desmos anyways. That's cool. I'm going to turn it on. And we have x squared plus 9x plus 18. As we do this problem, I am simply going to look for those x-intercepts, which are -6 and -3. And I can say, well, that is simply then x plus 6 times x plus 3, just looking at the graph on Desmos. That verifies that we did it correct, which is rad. That's what we use it for. Okay, so let's go ahead and let's go back. We'll do one more. We'll do it the old school method. And so let's do this. I set up the equation of y squared minus 6y plus 8. And it doesn't matter that we're using y's, honestly. So I'm going to take that y squared. I'm going to put 8 right here. And then I'm going to go back and I'm going to say, okay, well, I know that this is y squared -6y. And what that means is this has to add to -6y, and this value is 8. You'll notice I wrap those equations around. That's for as a reminder, polynomial division style stuff. And as we do this, we say, well, what is y times y? Well, y times y is y squared. And then we look for numbers that multiply to 8, okay? And remember, 2 positives multiply to 8, 2 negatives multiply to 8. So I've got 1 and 8, 2 and 4, 3 times 4 times 2. I've already repeated myself. And what I want to do is find out which ones add to -6. Well, I can make 2 and 4 add to -6 as long as they are both negative. So -2 plus 4 is -6, and -2 times -4 is 8. So that means I might put -2y and -4y. And once again, I would say, okay, y minus 4 and y minus 2. So maybe those are my factors. But you know what we're going to do? Nope, that should be a 4. Let's go ahead and go back to Desmos and check it out. Why not? We've got the opportunity here. We love technology. Let's go ahead and jump over. We graph it, and then we look for those x-intercepts, which are 2 and 4. And that tells us if we were to take those x-intercepts, put them in factored form, we just simply have x minus 2, x minus 4. The only difference in this problem is if we go back to the original problem, we're just using y's. That's it. Okay, so y minus 2, y minus 4. Every once in a while, we're going to get into another case like x squared plus x plus 3, where we get stuck. It doesn't necessarily work out the way we want it to work out. And I'm going to demonstrate that real quick. Let's say I had x squared in there. I take the x squared, I plug it right here. I put the positive 3 right here. And I say, okay, well, I know x times x is x squared. And then what I want are numbers that multiply to 3. Well, that is only 1 times 3 or -1 times -3. And what I want to do is, as I do this problem, I want to say, okay, well, there's my x squared, there's my 1x, so that these add to 1x. Well, there's nothing that will add to 1x that multiplies to 3. 1 times 3 is the only option. So what we say is this is prime, and it's as factors as it is going to get, unless we use another method to break this down. Okay, let's go to Desmos. Let's see what happens when I type this one in. Okay, I turn that one off. I go here, boom, x squared plus x plus 3 doesn't even have any x-intercepts. Check it out. And it's supposed to have 2, so that means there's 2 complex imaginary x-intercepts, but there's none that will go into the factors, the really nice factors. So in this case, it is prime, and we are done with that. I hope that helped with basic factoring.